So, Unit 6, Lesson 6. So, we're talking about the cosine law. Okay, the difference of the cosine law is we're going to use the cosine law when we can't use sine law. And you're going to discover right away on this warm-up when you cannot use sine law. Okay, so if I go to this warm-up, it says consider ABC, angle A is 36, AB is 3, and AC is 6. What happens when you apply the sine law? So let's do the sine law. So if I do sine law, I'll have sine of 36 over little a equals sine of B over 6 equals sine of C over 3. Remember, angles create sides. That's little a. This is little b. This is little c. That's where I got all that stuff. But the key component in the sine law is that you have to have a proportion already established. This one, we have 1 for all 3. So when you look at these, this, and this all have a missing value. So I don't have an actual proportion set up, so I can't use sine law. So sine law is not doable here. And that's when we're going to have to use cosine law. Okay, I'm going to kind of point this out now. You're going to be using cosine law a lot when you have side-angle-side relationship. It's called SAS, if you want to write that down. SAS is a good indicator to use cosine law. Because anytime you have a side angle and a side, that means that you're going to have the relationship that won't work for sine law. Okay? Any questions so far?
Which angle applies to which side?
Which angle applies to which side?
Yeah. You know it's opposite for sides.
Well, no, angles always create opposite sides. Is that what are you saying? So,
like if side A is like first angle A.
Right.
To solve it, like which side do you use?
Which side do you use? Oh, but for what though? Because like today.
When you're solving as proportion.
Right. When you're solving as proportion, in order to solve this as a proportion, Josh, I'd have to have another angle. And I don't, so that's the problem. So like if I had like whatever method, this was 66, now I could do it because I would have 66 here. Okay? The cosine law is going to help me solve this without having to have that extra angle. So let's just get to that. If there's something else I'm not understanding, maybe it'll be better here in a second. Okay, so let's see here. So use SOHCAHTOA in the diagram below to determine the length of BC, the nearest 10. So we're going to do these first two examples. We're going to do the long, harder way, just so that you understand where it comes from, and then it's going to kick out the formula for you so you kind of see it. Okay, so here's the deal. This is the same problem that we just had, and they went ahead and drew a dotted line to make it a right triangle. Okay, we do still have enough information here to solve for this side and this side. If I get these two sides, do you see this right here? This is a right triangle. I can now do what? Pythagorean. I get Pythagorean, get that missing side. So what I'm going to do is I'm going to go sine. So we're going to find CD first. So to find CD, I can use regular trig ratios because I've created a right triangle. So I can do sine 36 equals missing side, or CD, over the hypotenuse of 6. Opposite over hypotenuse. So then we can multiply the 6 over. So CD equals 6 sine 36. And when you calculate that, CD comes out to be 3.5267. That's what CD ends up being. Okay, anything there? And so now what I'm going to do now is I'm going to find AD. So if I get AD, I can get BD, right? By subtracting. So we're going to find AD. Okay, and finding AD, I'm going to go cosine 36 equals AD CD over 6. And again, I'm going to get AD equals 6 cosine 36, which AD equals 4.851. 8541, sorry. Okay. Now let's do a quick subtraction. 4.8541 minus 3 is 1.8541. So that is my BD length. And then we have our CD length is 3.5267. So now I can use Pythagorean theorem to figure out BC. So I can go 3.5267 squared plus 1.8541 squared equals BC squared, my hypotenuse here. And when you do that, you're going to get BC squared equals 15.8753, and we're going to square root, and it gets you approximately 4.0. So BC is 4.0. And then what it says there at the bottom is this method here can be a little more time consuming because you're doing a lot of different things. So now it's going to introduce to you the cosine law itself. So this is the cosine law. There's two forms of it. We're going to talk about this one first. And this one here, I would go ahead, if I was you, I would highlight it or star it, and I would put SAS next to it. This is best when you have side angle side. Right here, the cosine law. Okay, so what it's talking about here for our relationship that we just did is we didn't know little a. We knew the angle though. Okay, so the angle that you know goes on the end, and it's equal to the side squared you don't know. Okay, that's kind of how you fill it in. We'll do that in a second here. Okay, we go through this here. It's kind of the proof of it. It's a little bit complicated, but I'll just kind of walk you through it the best I can, and then we'll get to actually practicing the formula. So essentially, it's a formula. You do not have to memorize the formula. It is on your formula sheet, so you'll have it for your final and whatnot. So if you're worried about that, don't. Okay. All right, so the diagram shows triangle ABC. Place the base AB on the x-axis, so right here. Okay, and then it has A at the origin, same dot I just put. Line CD is drawn perpendicular, so that's this line here. It's drawn perpendicular, and we'll represent that as H for the height. Okay, AD is x units, and DB is C minus x. So the reason they call this whole side is little c, because this is angle C up here. So then that makes this little chunk C minus x. That's where they get that from. That makes sense? Okay, so then what I'm going to do first here is cosine A equals AD over AC. So cosine of A is AD over AC, so adjacent and hypotenuse. Okay, that's the same thing as x over b. That's where they got this from. So if cosine of A equals x over b, then x equals times that b over b cosine A. That's what we did earlier, right? So x equals b cosine A. Okay, so then let's look at this now. If we know for Pythagorean theorem, BC squared, so we have BC squared, that's this piece here, equals CD and DB squared. Let's change those letters to BC is A squared. CD is also H. They told us we can call it H. And then we know that DB is C minus X squared. So we're going to FOIL out that C minus X, and it's just for the proofs. Okay, you FOIL that out, you get C squared minus 2CX plus X squared. This is where it kind of gets tricky. So H squared plus X squared. H squared plus X squared is equivalent to B squared. x squared and h squared from the other triangle is equivalent to b squared. So they replace this with b squared. The same thing. Okay, and they simplify this one down, okay, by taking the x, they're going to replace the x with this right here, b cosine a. So this x right here, they put in the b cosine a for it. Okay? Like that. And then, hence, this is the formula. That is the law of cosine. Okay? All right, and again, it says here at the bottom, what I've been pointing out since the beginning, this formula is best for SAS. Okay? All right, let's get to the example here. We're doing the same example we've been doing. We're actually going to do it using the cosine law now, so you'll see how fast it is. This is the same problem we've been doing. So let's write out the formula one more time. So we know it's going to be a squared equals b squared plus c squared minus 2ab cosine of c. Or a, sorry. Cosine of a. So I plug all this stuff in. We don't know little a. See, we don't know little a, but we know everything else. That's why this that's why we like it. Okay? Here, let me label everything for you. This is little c. This is little b. This is big A. And then little a is what we don't know. So when you come over to the right side, everything will be filled out. B squared, 6 squared. C squared, 3 squared. Minus 2, 6, 3. Hold on here. Sorry. I've got my A and B's mixed up here. I put it in here right. It should be BC. Okay, and then cosine 36 degrees. So you just put this all in your calculator. That's just calculation right there. Okay, and you put that whole in your calculator, you're going to get, again, we already seen this number, but we're going to get 15.8753. Square root for A, square root for A. A is about 4.0. Same thing there. Okay. All right. Let's get to example 3 here. And they may change the letters on you. Okay. They may change the letters on you, but you're still just going to think about it A, B, and C. Okay. You're still going to think about A, B, and C. So find the length of the nearest tenth of a centimeter, the third side. So let's look and see what we have. We have QP is 1.7. We have QR 3.1. And angle PQR, so that's this angle, is 110. Okay, it says the third side, so we're trying to find this side here. Okay, we can't use sine law, because again, it's what? Side, angle, side relationship. So I'm going to go little q, this is my little p, and that's my little r. Okay, so we're going to go q squared equals 1.7 squared plus 3.1 squared minus 2, 1.7, 3.1 cosine of the angle, 110. That's your calculation. That's going to give you little q squared is 16.104 square root. Little q is going to be about 4 again. We keep getting 4. No, it's just coincidences though. Okay, if you have problems with calculation, I can look at it. You have something wrong enough? Just make sure you're in degree mode. Let's see here. Give you a second to try it yourself. So I got 16.10. Okay. Any other issues? All right, so example 4. All right, example 4 here. So Bellevue is 30 kilometers north of Ayer, and Churchville is 18 kilometers northwest of Ayer. Calculate the distance between Bellevue and Churchville to the nearest kilometer. So let's see here, Bellevue's 30. So we have Ayer, 30 meters or kilometers, excuse me, north. That's going to be Bellevue. Okay, and Churchville is northwest. So northwest, we're going to go to about a 45-degree angle, and it is 18 kilometers. And this is Churchville. So that's what your should look like, and it's not coincidence. It's ABC set up for you. Okay, and what you may not know, though, if you're going northwest, it's automatically assumed it's 45 degrees. It's 45 degrees because you have north. Okay, you have west, you're going halfway between there, you're going 45 degrees. The 90 degrees, right? Okay, and then, thank you. Okay, and then, now we can set it up. So I want to look for little a again. Okay, so I'm going to go a squared equals 30 squared plus 18 squared minus 2 times 30 times 18 cosine of 45. Okay, give you a second to try to calculate that in your calculator. You should get something like this. A squared should be about 460.32. Our last step is square root. Should get A is 21.45. It says round nearest kilometer, so that means we'd want 21 kilometers. So that means this distance up here is about 21 from Bellevue to Churchville, sorry, not Hill. Okay. All right, so that's it for that one. And so now we're just going to show you there's one other time when you want to use cosine law. And this is the other form of it right here. Okay. That's the other one you want to use. And you want to use that when you have side, side, side. Because if you have all three sides, you don't have the angles, and it's the same thing. You're going to have one from each piece.
Will we be given these formulas?
Yes. These formulas are on that same formula sheet you've always had. It's on there. Okay. Anything else? Okay, so what this is asking is if cosine B, notice the pattern, okay, it's the other two, not A, so BC squared minus the A over the 2BC. So if I was doing this one with that same pattern, right, yes, you won't have any angles. Okay, this is A squared plus C squared minus B squared over 2AC. That's how that one would work. Okay, hopefully you're noticing the pattern. The third one, or the second one, excuse me, would be B squared plus A squared minus C squared all over 2AB. All right, let's just continue. I'll let you guys get that down, and we have 2 more examples, and we're done. Okay. All right, so final 2 examples here using this form of cosine law. It's the same law, just altered. So see, it says determine the largest angle of ABC. Let's cheat here. Let's get a triangle. Whoops. So we got a triangle. Okay, and we have, we'll go A's here, B's here, C's here. It says side A is 14.7. Said side B, and this is obviously on scale, but side B is 8.9. Side C is 12.6. Okay, so here's the thing. It says to find the biggest angle. So we're going to have to do this 3 different times to find that? No, we're not going to have to do it 3 different times to find it because the biggest angle will make the what? The biggest side. So all I got to do is find that one. Because biggest angle makes biggest side. That has to happen. Okay, so that means we're going to be doing cosine of A. So that's going to be 12.6 squared plus 8.9 squared minus 14.7 squared all over 2, 12.6, 8.9. Give you a second here, but when you calculate that, I'll let you try it, but hopefully you get this. And then we'll talk about the last step in a second. You should get 0.0975. Okay, did you get that time? Okay, and then what do we want to do? How do I find, what was my last step? Right, second cos or cosine inverse of 0.0975. We'll kick out your degrees, and it should get you 84 degrees. That's the biggest angle of the triangle. Okay? All right, we got one more. See if I can challenge you on this one here. All right. So this one, 2 ships set sail from Port P, heading in different directions. The first ship sails 7 kilometers to R. It's got labeled for you already. This goes to 8 kilometers to Q, and they're 13 kilometers apart. Determine the angle between the directions of the 2 ships. So we want to figure out the angle between the directions, right there. Obviously, that's going to be the biggest angle because it's from the biggest side. Okay, so that's something to keep in mind. All right, and now the next thing I want to do is we'll set up our same deal. So I'm essentially, in this case, I'm looking for cosine of P. Okay, and that's going to give me 7 squared plus 8 squared minus 13 squared all over 2, 7, 8. Now get that, tell me what you get. This is kind of an important point. Tell me what you get there. Got it? It's a negative number, yeah. Negative 0.5 what? Oh, at the top. Yeah, then just divide it. Oh, that's not quite right. No, you guys are calculating a little bit wrong. Yeah, it's negative 0.05. What you have right there. Yep. Negative 0.5 is what you should get. Okay, now think about your unit circle. Cosine's negative. So what quadrant am I going to be in? Second or third, and we can eliminate the third because we can't have any angles bigger than 180, right? Because it's a triangle. So that means my angle's in here. So what's that mean about this angle? What kind of angle is it? It's bigger than 90, so what do we call that? It's obtuse, okay? So noticing that that's obtuse is kind of a key component there. And then when you put in inverse in your calculator of negative 0.5, it kicks out 120, which is correct. Okay, real quick, I'm not for sure, but Sarah, can you look on your unit circle and tell me, because on your unit circle, what is negative 1/2 in quadrant 2? For cosine, for x. In this one? It's which one? Is it this one? It's up top? Okay, and so then that would be, yeah, so that would be 30 here, right? 30 plus the 90 is 120. I'm just connecting it together. So cosine negative 0.5 on your unit circle is the same degree. Okay, sorry. All right. Okay, that's it.